In this video, we're going to look at Newton's third law. Newton's third law says, for every action, there is an equal and opposite reaction. And this law highlights the fact that forces always act in pairs. There's not going to be one force. There's got to be a complementary force someplace else. And sometimes we just have to find it. This law is sometimes called the law of action/reaction. Law of action, reaction. All right, I want to go through some examples of some of the complementary force pairs. And so to do that, we're going to go back to our notes here. All right, so very quickly, I tried to write some in just to make our notes go a little bit faster. So let's say that we had a block sitting on the ground. I'll use my calculator since it's sitting right here. All right, so block pushes down on the ground, ground pushes up on the block. Or calculator pushes down on the table, table pushes up on the calculator. The key thing is there has to be two nouns. So there's a block and there's a ground. And then the direction has to be opposite. So the block pushes down on the ground and the ground has to push up on the block. That's how you know you have found the correct force pair. All right, the next example is pulling on a spring scale. At school, I have a good spring scale that I can use, but I don't have that here, so I'm going to think of the spring scale you see hanging in the produce section at the grocery store. Like you'd put your bananas on the spring scale to find out how many pounds of bananas that you have. So the bananas pull down on the scale. That means that the scale has to pull up on the bananas. And people sometimes forget about the up part. All right, now I'm just not going to write as detailed, but leaning on a wall. So I could push left on a wall, and that means the wall has to be pushing back right on me. The wall has to be pushing back in the opposite direction. If this force pair wasn't here and I was pushing on the wall, then I would be knocking the wall over. So the reason that the wall doesn't fall over is because the wall has to be pushing back on me. All right, kicking a soccer ball. If I kick the soccer ball with my foot kicks the soccer ball. That means the soccer ball kicks my foot. And so it goes both ways. Swimming. How do I swim? When I swim, I push the water backwards. Picture somebody doing kind of like a breaststroke. They're pushing the water backwards. And if you push the water backwards, then the water is going to push you forward. So you don't get to swim unless you move the water backwards. And then the water will propel you forward. All right, stepping out of a canoe. Maybe you can picture this. Stepping out of a canoe at a dock or stepping out of a rowboat at a dock. So if I step forward, the canoe goes backwards. So I didn't list the detailed force pairs, but you can see that I have one action and I have a reaction happening. Walking across the room. Walking across the room is the same thing as swimming. So in order for me to walk forward across the room, I have to push the earth backwards. I truly push the earth backwards. And then the earth will propel me forward. And so again, we don't always see this because the earth is so big, but it does happen. So another example that's kind of like walking across the room in terms of moving the earth is what I'm going to call jumping up. And so this is my picture of jumping up. When you start to not believe it, sometimes you just have to look at it from a different perspective. So this is the earth. This is you, and we're going to pretend that you can jump up like really, really high. Okay, so you're going to jump up here. So when you're up here, you and I know that you're going to come back down. So the reason you come back down is because the earth is pulling you down with a force. We could call that the force of gravity by putting a little g there. All right, so the earth is going to pull you down. Well, now in this lesson, I'm saying that if the earth pulls you down, you are also pulling the earth up. Equal and opposite, which means the force that you pull the earth up is equal to the force that the earth pulls you down. These F's are equal, equal and opposite, action, reaction, equals, equals. But now let's add Newton's second law on top of the third law. So here's me. I have a tiny m. Here's the earth. It has a really big M. And if the F's have to be the same, if they have to be equal and opposite, then in order for me to get the same F value, I'm going to have a big A, and the earth is going to have a very tiny a. That means that when I jump up, all you ever notice, all you see is my big acceleration falling back down. You don't see the earth's teeny acceleration going up towards me. So I'm kind of exaggerating my picture here, but maybe the ball moves up just a teeny bit, and then you come down and your feet are on the ground. Now, obviously, in real life, your mass is way, 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 way smaller than the earth, and you are barely going to budge that ball. But people always ask the question, what if we could get everybody on earth to stand right here and get everybody to jump up? Yeah, you could maybe make the earth wobble, all right? The Newton's third law says that you could make the earth wobble and you could move it up a little bit. Okay, so why when you jump up into the air, you pull the earth up? Why do we not notice the effect? Because we have such different masses, we are going to end up with different accelerations. All right, and then the last thing here is just a chance for you to identify some force pairs. It's just a picture, but I'm going to switch here so you can see my picture better in my PowerPoint, I think. All right, so we have a picture, and in class I would ask you to identify some force pairs. So you could say something like this. Wheel pushes on ground, wheel pushes down on ground, the ground pulls back up. The wheel pushes down on the ground, so the ground has to push back up on the wheel. You could say that the donkey pulls on the cart, so therefore the cart has to be pulling on the donkey. I'm guessing that that's what those two red arrows are. You could say that the donkey is pushing the earth backwards, and so the earth is going to propel the donkey forward. I don't know what these little sacks are, but let's say the sack pushes down on the cart, then the cart would push back up on the sack. So you're always just looking for two things, two nouns that are acting in the opposite direction. All right, that's a great intro to Newton's three laws, and that'll get us started, and we'll be adding on some more detail as we continue through the unit. Thank you for listening to all of the videos.